Welcome to Supply Chain Horizons, our video podcast series that looks at crucial issues facing global supply chain teams. This video podcast is sponsored by Logility, a leading provider of supply chain solutions used by more than 1,250 companies in more than 70 countries around the world. You can access this podcast and many others by visiting www.logility.com and just click on the library link. So let's get started. I'm Corinne Bursa, Vice President at Logility, and I'd like to share with you some enlightening conversations that I've been having with supply chain innovators and industry insiders. Today we're checking in with Dr. John Slater, Vice President of Manufacturing Planning Solutions at Logility. John, we appreciate you spending time with us today, and it's great to have the opportunity to tap into your expertise as a practitioner, as a teacher, and as somebody who's been driving innovation around optimizing production environments. Thanks for joining us.
My pleasure.
You know, the topic of today's session, Taming Transition Turmoil in Process Chemical Scheduling. It's intriguing. It's hard to say, but it's intriguing. What causes transition turmoil in the process chemical industry?
Well, I'm glad the title piqued your interest, Corinne. Transition has multiple meanings when we're talking about production scheduling. In semi-continuous operations, things like plastics resin manufacturing, for example, a processing line may have to run without stopping, but it's not typically dedicated to just making one product for a very long campaign. We want to make switches, different products or different grades, and those different changes to the product are made by varying the input formulation or the operating conditions. When we change from one grade to the next, it's usually a gradual transition, and it's produced without physically stopping the equipment. We can envision this easily if we think about extruding a material that changes color, maybe from a white to a dark. In between, the output would be a gray. Something similar happens during the product-to-product transition. In between, we can produce a wide-spec product that has different characteristics from either product, maybe not exactly what we're trying to achieve, but it would be potentially a usable product. The quantity of the transition product, as well as the time as it takes to complete that transition, will usually depend on the specific products on either side of the transition, and therefore we can have what we call sequence-dependent transitions. In this way, the sequence-dependent transition is similar to a sequence-dependent changeover, which is something we'd see more in discrete operations like a packaging operation. There are a couple of important distinctions, though, about transitions that make it a bit more challenging to handle. First, during the transition, the line doesn't physically stop. The material consumption continues, and the wide-spec transition product continues to be produced. A discrete changeover, on the other hand, is usually a lower bound. It might take 30 minutes to switch from filling totes to boxes, but there's nothing to keep the successive operation from waiting longer, maybe to the start of the next shift. With the transition product, the line keeps on producing, and we don't really have the luxury of stopping. Second, because the cost impacts of the product transitions can depend greatly on the sequence, it might be more economical to produce an intermediate grade of product, even if we really don't have any demand for it in the near term. And this push-type scheduling can lead to inventory builds across sets of products that we're following an optimal wheel to produce, and those inventory builds need to be managed. This can lead to constraints in storage that can be a challenge. The optimal wheel usually drives the production in relatively long campaigns. And if our customers could only create their demand signals to follow that product wheel, the job of the planner would be a lot easier, but they generally don't.
Yeah, I think if we could work with our demand signals in that way, that would solve a lot of problems. But that's part of the challenge, right, is being responsive to changes in demand or responsive to changing demand signals. And I want to explore this just a little more, John. You know, some of these challenges around synchronizing both the long-term planning and the short-term scheduling, you know, how do you do this? How do you bring these views together when you can't stop production?
Often it isn't practical to break the optimal sequence. The way we respond is typically by shortening or lengthening the campaign in order to allow us to adapt to those variations in the demand signal. But to do this, we've got to have visibility across a long planning horizon, typically several weeks or months, as opposed to the more shorter scheduling horizon we would see in a discrete operation. This leads us actually to the second meaning of a transition, and one that's more related to the transition of a planning methodology from that which we might traditionally use for long-term planning to the short-term scheduling. Some scheduling solutions are limited in their horizon to a few days or a few weeks, and a long-term planning solution might use monthly buckets in which they don't really have any concern about the sequence of products within the month. And this planning transition that we see from a monthly bucketed system to the more detailed scheduling solution that is going to really have a builds and falls of individual products, that transition can create a gap really between the scheduling horizon and the planning horizon. The inventory sawtooth pattern that we expect to see out of a sequence solution really falls apart at that transition boundary, and that makes it a challenge for the schedulers to pick up where planning leaves off. I've often heard schedulers refer to this as waiting for stuff to fall on us. The important time phasing that we need to see from a scheduling according to a product wheel, and that product wheel really being driven by these transitions, can get out of kilter. And effectively what that means is the end of your scheduling horizon isn't very effective in terms of managing to the demand. It's kind of like starting up a new plant when you had no initial inventory. All the products would be out of phase until you can get sufficient cycle stock built up to bridge the demand between those successive campaigns. A second challenge that we see really comes with the inventory management of those semi-finished products, the bulk products maybe not yet in a package, or a semi-finished good that might need some other operations. Because the optimal transition sequence is going to drive typically production of products that don't have immediate demand, it might be more economical, for example, to produce a product rather than to drop it out of the sequence because we would otherwise take a much higher transition change. That production, that sort of push production, can create an inventory buffer between the different manufacturing stages, between upstream and downstream operations, and that can simplify our packaging planning. But it also creates an inventory management challenge. If we don't have local tank or hopper storage right near the processing line, it's not unusual to use rail cars to hold some of the finished goods, the overflow products, those semi-finished goods. And these quantities that we've already produced would be physically within the plant and measured within the inventory management system of the plant, but they might actually be on a remote siding somewhere that would require 1 or 2 days to get it back to be able to work in the packaging or processing unit. And so what this means as another complication is that the measurement of inventory needs to be segregated, perhaps between inventory and nearby tanks versus inventory and rail cars that's physically on site but might not be available for a couple of days and needing advance notification. So some of our customers actually model that by bringing in future receipts to reflect an inventory of a semi-finished good that isn't available today but could be available in 1 or 2 days out in the future.
And that really helps them kind of leverage both their storage resources as well as the production environment. I'd like to thank Dr. John Slater, Vice President of Manufacturing Planning at Logility, for his valuable contributions to our discussion today. John, thanks so much.
My pleasure, Corinne. I'm happy to speak with you.
Supply Chain Horizons is sponsored by Logility, a leading provider of supply chain solutions used by more than 1,250 companies in more than 70 countries around the world. You can find all our podcasts at www.logility.com. Just click on the library in the main menu navigation bar. And while you're there, we hope that you will also download one of our valuable white papers that cover a variety of supply chain topics. We also invite you to connect with us on LinkedIn, Facebook, and Twitter. That's it for today. Thanks again, and please join us next time for Supply Chain Horizons.